Okay, and we are getting into the idea of Lagrangian formalism. Already I told you that L is a function of q dot and t, right? Q dot and t, and L is given as t, L is equal to t minus t, which is kinetic energy and potential energy. And Q's and Qy's are generators, coordinate and generates velocities. The equations of motions are derived from the help of the Euler-Lagrange's equation which is d by dt of dou L by dou Qi dot minus dou L by dou Qi equal to 0 for conservative systems. Right? Okay. So here we have a first problem here. They gave equations of motion, right? There's a bead, right? There's a bead which is sliding in a rod, right? Which is the rod is in a vertical plane, right? And it has a uniform angular velocity. These are the informations given in a problem, right? Once you have uh, the system, we are able to write the kinetic energy and the potential energy. Here, the generalized coordinates, here we are going to use is theta and r. These are the two minimum coordinates which is required to describe the system. Okay, these are the sufficient number of coordinates or sufficient number of coordinates we are able to describe the system, right? So since it consists of theta and r, we are dealing with the cylindrical coordinates, right? So the for the kinetic energy, we instead of mv square, we have mr dot square plus r square theta dot square. So these are the terms. Once you transform from Cartesian coordinate to cylindrical coordinates, we are going to get this, right? So then we have a potential energy which is mg y. Here we have y. It is given as the rod is in a vertical plane, and the bead is sliding with a smooth riding on a smooth form. So then we can write mgr sin theta since it is on a vertical plane. It is given as r sin theta, and the Lagrangian, which is a function of q dot and t. Here we have two coordinates, which is r and theta. So will be having r dot and theta dot, right? We don't have t explicitly in the system, right? So we have it is a function of r theta dot, r theta, r dot and theta. Once you write the Lagrangian, let's check with this, right? So it is equal to, which is t minus v. We can write it as of m r dot square plus r square theta dot square, and we have minus sign mg r sin theta, right? This is here, right? Once you have here, then we just get into solving the Euler difference. Since we have two coordinates, make sure you have r and r theta dot and r dot theta dot. So here we have r theta, r dot, r theta dot, and we have r here and theta here. M and G are constants. We don't want to bother about that, right? So once we have this, right? So we are able to write the Euler-Lagrange's equation for the r coordinate and theta coordinate separately. So d by dt of dou L by dou r dot minus dou L by dou r equal to 0. This is the first equation. And second one, which we are going to use is d by dt of dou L by dou theta dot minus dou L by dou theta equal to 0. First we will solve this. So dou L by dou r dot. So dou L by dou r dot. So once we have r dot, in this term only you will be having r dot. So you will be getting dou L by dou r dot is equal to m r dot, and d by dt of dou L by dt by dou L by dou r dot, which is m r dot, which is equal to m r double dot, and we have dou L by dou r. R term is present in both these terms, that is this term and this term, right? So once we differentiate with respect to r, we are able to get 1 by, this is m r theta dot square and minus mg sine. So these two terms you are able to get with the help of r coordinate, right? So then we have to write the another term, which is dou L by dou theta dot, dou L by dou theta dot, which is equal to, here we have theta dot, so we will be having m r square theta dot, and once you differentiate with respect to d by dt of uh, m r square theta dot, we will be getting m r square theta dot. So, since we have another condition which is given here, is the uniform angular velocity. So once we solve this step for this coordinate, then we will get into how we have to take this, right? So then we have, once we wrote d by dt of dou L by dou r dot and dou L by dou r dot, we can write mr double dot, and we have minus sign which is in this equation. So just minus mr theta dot square minus will become plus, and we can write mg sine theta equal to 0. Well, so we have a condition, uh, that is, we have the uniform angular velocity, so we can write it as theta dot equal to omega, uniform angular velocity. So we have d theta by dt equal to omega. For the time being, get rid of this. We don't need this, right? So then we can write d theta equal to omega into dt, and once you integrate this, theta equal to theta is equal to omega t. Okay, you can use this theta value in this equation, right? So m r double dot minus m r, instead of theta dot we can use omega, and we have a square here, and plus mg sine, instead of theta we will be having omega t, and this is equal to 0. Once we rearrange this, we are able to get the equation. This mr double dot equal to mr omega square minus mg sine omega, just the given equation in the problem, right? So we arrive at the equation of motion of a given problem. Okay, we can discuss another problem in the next week.